Okay, continuing the review problems. Number 104, you're asked to find the derivative using implicit. Y squared equals x minus y times x squared plus y. Alright, there's several things we can do here. We can go right to the derivative. Then we would need the product rule on the right-hand side. Remember to look to simplify anything possible. So I think I'm going to try and expand that binomial. First, outer, inner, last. Now I still need the product rule on xy and x squared times y, but at least now I have x cubed and this negative y squared term by itself. Alright, so if we continue, let me subtract this y squared. So now my function's set equal to 0. So minus 2y squared. Now if we find the derivative of 0 is 0, derivative of x cubed is 3x squared. Now xy needs the product rule. First times the derivative of the second plus second times the derivative of the first. So this is just the derivative of xy. Now I'm going to subtract the derivative of x squared y. First times the derivative of the second plus second times the derivative of the first. So this is the derivative using the product rule of x squared y minus 4y times dy dx. So that's the derivative of the negative 2y squared term. Alright, so 3x squared plus x dy dx plus y, distribute that negative, minus x squared dy dx minus 2xy minus 4y dy dx. One second. Okay, now, okay, so this is what we have for the derivative by implicit. So now I'm going to keep the dy dx terms on the right hand side of the equal sign and move the terms that don't have the dy dx. So here, here, and here, I'm going to move them to the left hand side of the equation. So negative 3x squared minus y plus 2xy. Now on the right hand side, I'm going to factor out the dy dx. X minus x squared minus 4y. Then to solve for dy dx, divide both sides by that entire factor, x minus x squared minus 4y. That's my derivative. Mod 2, we did this in class. Y square root of x minus x square root of y equals 25. So when we derive this with respect to x, we're going to need product rule for both terms. First times the derivative of the second plus second times the derivative of the first. So this is the derivative of y root x minus first times the derivative of the second. Since it's the y term, we need the implicit, plus second times the derivative of the first. Derivative of 25 is 0. So this is the derivative of the x root y term. Okay, so let's now make positive exponents. Clean up what we have. Distribute my negative with positive exponents. Okay, so on the left hand side I'm going to keep the dy dx's and I'm going to factor that out. Then I'm going to subtract the terms that do not have the delta x in them. Okay, now look on both sides of the equal sign. We're going to need common denominators here. Okay, so common denominators on the left-hand side. Common denominator is 2 root y. So I'm going to need to multiply the first fraction by that 2 root y. So now I have 2 times the square root of xy minus x. So when you're taking the square root of something times the square root of another term, we can just multiply what's underneath and keep the one radical. So this is my dy dx. Okay, now on the right-hand side of the equation, I'm also going to need a common denominator. That common denominator is now 2 root x. So the first term will need to be multiplied to get the common denominator. So now we have negative 2 root xy minus y. So then solving for dy dx, the right-hand side, we don't do anything more to that. We're going to multiply it by the reciprocal of what's being multiplied by dy dx. Nothing needs to be canceled. It's not pretty, but that's your final answer. Okay, 108. Cosine of x plus y equals x. Taking the derivative of this with respect to x. Working from the outside in, derivative of cosine is negative sine of what follows it. Derivative of the inside, derivative of x is 1 plus the derivative of y is dy dx equals 1. So I believe we did something like this. The goal is to solve for dy dx, so let me get rid of this term. These cancel. I'm left with 1 plus dy dx. On the right-hand side, the reciprocal of the sine function is the cosecant function. And then let me subtract 1 from both sides. So negative cosecant of x plus y minus 1. That would be your final derivative. If you didn't see to divide by the negative sign term first, you would then have to distribute it to both terms, add a term to the right-hand side, and divide anyway. So look to simplify using any type of algebraic technique that you have. Okay, so this is it for the problems I had you do here. The related rate problems, go over the 3 that we did in class, focus on them. Right triangle, Pythagorean theorem, right triangle trig, and area, and then the volume of a cone using similar triangles. Okay, now let's look at, I was asked to talk about instantaneous versus average rates of change. So this is the homework from section 2.2. So I'm on page 117. Numbers 93 to 96. It says find the average rate of change of the function on the given interval. Compare that rate of change with the instantaneous rate of change at the endpoints of the interval. So let's look at 94. T squared minus 7. Let's not. Yeah, t squared minus 7 on the interval from 3 to 3.1. T squared minus 7 on the interval from 3 to 3.1. So this is 94 on page 117. Okay. Average, that's the change in the function over the change in time. That's your slope formula. So we need f of 3.1. This is okay. I knew that something was awry there. This should be a 9, 9.61. So then we get 9.61 minus 7 is 2.61. All right, so the average rate of change, subtract the y values, divided by the difference in time. So the difference in time here is 1/10. So this would give me 0.61 divided by 0.1. So this would give me, so my average rate of change on the interval is 6.1. Okay, so now the instantaneous is the derivative. So the derivative of the function is 2t, and it says compare it to the instantaneous rate of change at the endpoints. So f prime of 3 would give me 6. F prime of 3.1 would give us 6.2, just doubling that. So the average is right in between the instantaneous rate of change at the endpoints. All right, let's go back to these. Now, just to make it more of a type of problem that I would ask you for, I believe 97 was like a homework. I asked this, and I wouldn't ask you for D to complete D and E. Okay, silver dollars drop from the top of a building. Let's look at 98 since you don't have Calc Chat. A ball is thrown straight down from the top of a 220-foot building with an initial velocity of negative 22 feet per second. What is the velocity after 3 seconds? We'll answer parts A through C. Okay, so negative 16t minus 22t plus 220. So f of t, negative 16t squared minus 22t plus 220. And let's use, so that's the position. And what page are we on here? Page 117, number 98 is the problem that we're using. Page 117, number 98. All right, so let's see, what does it ask? Position and velocity, average velocity, instantaneous. So position we just found, velocity. B asks for the average velocity on the interval from 1 to 2. So I'm just using the parts from number 97. And then C is the instantaneous velocity at 1 and 2. All right, so the position function's given. The velocity is the first derivative of the position function, negative 32t minus 22. The average velocity, that's the change in the position over change in time. So you would find the position at 2 seconds, find the position at 1 second, and then divide it by 2 minus 1. In the essence of time, you can do that problem. And then part C, find the velocity at 1 and 2 seconds. Well, we found the velocity function to be negative 32t minus 22. So the velocity at 1 second would be negative 54 feet per second. The velocity at 2 seconds, that would be negative 64 minus 22, so negative 86 feet per second.